This project is going to be a command line application that runs on our local machines using Node.js. The purpose of the application is to crawl a website and produce a report of the internal linking structure of the website. Basically, which pages link to which other pages on the site. This is a tool that would traditionally be used by kind of web marketers or SEO, search engine optimization experts. So I'm here on my personal GitHub account, and I usually start by just creating a new repository for whatever project I'm starting. So here I'm going to go ahead and call it web crawler HTTP project for the Learn HTTP course. I'm going to go ahead and make it private. You can keep it public if you want, whatever you want. I'm going to automatically initialize it with a readme.md file, and that should be all I need to do. Go ahead and create that repo. I am working on Mac OS, but everything we do should work just fine on Linux and Windows. You may just need to install things slightly differently. I'm also working in VS Code, my editor of choice, but again, whatever editor you prefer will be totally fine. I'm going to go ahead and clone down that repo that we just created on GitHub. Now that we've cloned the project down locally, I'm going to go ahead and install NVM, or the Node version manager. If you just Google NVM, you should be able to find the GitHub page where you can download or where you can find the installation script that I'm about to use. But I'll also include a link below in the description GitHub page. So I'm going to run that install script, and I already have it installed, so it doesn't even do anything. But just so you know, that's what you would run to install NVM. Once it's installed, we'll add a .nvmrc file to the root of our repository. And inside, we are going to add the version of Node that we want to be using, which in this case is going to be 18.7.0. You can use a newer Node version than this probably, but I wouldn't recommend going much older than 18. Once we have that nvmrc file created, we can do a nvm install, and that's going to download Node version 18.7.0 if we don't yet have it. And then once we have it installed, we can do nvm use, and that will switch the current version of Node that we're using in our shell. And then just to check, we can do node -- version to make sure that we're on the right version of Node. Next, let's run a little program just to make sure everything's working properly. I'm going to create a main.js file, and we'll just have it log hello world to the console. And then from the command line, we should be able to just run node main.js. So this starts the Node interpreter and passes in main.js as the entry point. And it logs hello world, so we're good to go. Running Node kind of manually from the command line, like node and then the name of a file, it works just fine. But because we're going to be installing a test suite and packages, we're actually going to use npm to manage all of that kind of environment and ecosystem. So in order to get that going, we just run npm init. And it's going to take us through kind of a little interactive setup. And I'm just going to press enter a bunch of times to use all the defaults. And it will create a little package.json file. Again, with a bunch of kind of default values. The only thing we need to change at this point is we need to add a new script, and I'll just call it start, that runs node main.js for us. So now instead of manually typing node main.js into the command line, we will type npm start. And that's just going to call this little script here. Again, the purpose of this is now that we're using a package.json file, when we pull in dependencies and run our code through npm, the dependencies will be available to our code. Similarly, we'll be using npm to run our tests, so it's just nice and convenient to have everything in the start command. Cool, and it worked, right? It logs out current version of Node and then runs the program. Next, let's go ahead and install Jest. So we're going to be doing some test-driven development as we build out this project. And in order to do so, we need a test suite. So we're going to install Jest, a fairly popular testing runtime. And we can do that by typing npm install --save -dev jest. And that should update our package.json file with a new dev dependency, as well as install the code in the node modules folder and create a package lock.json file, which just keeps track of all the dependencies in our project. So there it is. That looks good. Like I said, the package lock.json is an auto-generated thing. You can just leave it. Same with node modules. But we do need to ignore. So let me create a new file called git.gitignore. We do need to ignore this node module folders, or this node modules folder. And the reason for that is the node modules folder contains all of the dependencies for our project, and it's actually quite a lot. Jest has a lot of dependencies. And so we don't want to commit that code to our repository. We just want the code that's kind of unique to our application. So we'll keep track of our dependencies in the package.json, which is committed to our source control. But we are not going to commit the node modules. Anytime we pull down this repository fresh, it won't have the node modules. So a developer will just need to type npm install in order to install all of the dependencies kind of listed here in the package.json. And then they'll get their own copy of that node modules folder. So now that we have Jest added as a dependency, let's add a script that actually runs it. If we were to run npm, let me clear this out. If we were to run npm test right now, all we'd get is this error no test specified. And that's because here in the test script, all we're doing is echoing error no test specified. So let's swap this out for Jest. And now if we run npm test, we get something a little different. It says no tests found, exiting with code 1. Okay, so we're properly calling Jest now. We just need to add some tests. Before we get to adding some tests, let's go ahead and commit what we have to Git so we don't lose it. So I'm going to do a git add dot. This adds everything in the working directory to kind of the Git staging area, ignoring everything that's ignored. So you can see node modules is in gray. That's because we added it to the git ignore there. Then we'll do a commit where we say added Jest dependency and created a main.js file. And then we can push that up to Git. The first function that we write tests for is going to be called normalize URLs. And I'm going to create a file called crawl.js to write that function in. So usually when you're doing test-driven development, there's kind of 3 steps. The first step is to stub out the function that you want to test. The second step is to write the tests for the function. And then the third step is to go back and actually implement kind of the meat of the function. So first, let's stub out the functions. It's going to be function normalize URL. And as input, it's going to take a URL string. So a string representing a URL. And it's going to return a string. For now, I'll just return a URL string. Again, this is kind of a stub function. It doesn't really do anything interesting yet, but it allows us to see, what's going in and what's coming out. Next, let's go write the test file. So it's going to be crawl.test.js. And the way Jest works is that it just automatically looks for files in your package or in your folder, project directory, that end in .test.js. So it is important that we name it with that suffix. Let's hop back over to the crawl.js file and we'll add a module.exports. And this will make the normalize URL function available to other JavaScript files that want to import it. So now we can hop back over to crawl.test.js and we can import that function. It's going to be const normalize URL equals require, and then the path to that file, which is crawl.js. That imports that. And then we also need to import 2 more functions, this time from Jest. They'll be the test and the expect functions. And so we can require jest. I think it's at jest. Cool. Let's write our first test. So the way testing works with jest is there's kind of this top level test function, and it takes as its first input the name of the test. So I'm going to call it, for now, just normalize URL. That is the name of our function, right? I'm not crazy. Okay, normalize URL. The second input is a function. So let's go ahead and write an empty function. Within the function, we can use this expect function to do a test. Let's start by specifying what's the input to the normalize URL function. For now, I'm going to just call it input, and we'll just use an empty string. Next, I'm going to run the function and get some output. So const output equals normalize URL and give it the input. Okay. And actually, I'm going to change the name of output to expected, just to be a little bit more clear. Sorry, not expected. I'm crazy. To actual. So this is the actual output of our normalize URL function. Next, I'm going to specify the expected output. So expected, what do I expect to come out of the function? And again, for now, I'm just going to use an empty string. Finally, we can use the expect function. So expect, give it the actual result of the normalize URL function, and then use the .toEqual method and give it the expected. So this line basically says, I'm expecting the actual output of normalize URL to equal the expected output that I've specified. If they do equal each other, Jest will log it as a passed test, right? Test is good. If they don't equal each other, then Jest is going to say the test failed. So let's go ahead and run that and see what that looks like. So again, because we have Jest specified here as a script, I can just run npm test. And the test passed, right? Which actually makes sense because we specified the input as an empty string and the expected as an empty string. And right now, all our function is doing is returning the string it was given. So let's see if we can get it to break really quickly. Something else. So I'm changing the expected value and running npm test again. And now we get a failed test, which makes sense, right? We expected the string something else, and we received the empty string. So now let's talk about what the normalize URL function is actually supposed to accomplish. Sometimes on the internet, there are different URLs that all point to effectively the same page. Let me give you an example. So something like https://boot.dev, right? This string, it points to the boot dev homepage. Effectively, this URL also points to the boot dev homepage. They're really the same page, right? One has HTTPS specified, one has HTTP, but it's really the same web page, right? Similarly, if we capitalize the B, again, it's a different string, same page. So what we are trying to do with the normalize URL function is find, well, it's to take a URL as input and normalize it so that the output will be the same for all other inputs that are the same page, right? So basically, if all these strings are put into the normalize URL function, we want the same thing to come out the other end. So for example, this might normalize to boot.dev. This also normalizes to dev, and this normalizes to boot.dev. Right? We want to normalize different strings to the same strings if they represent the same web page. So let's erase all of that. And let's build an actual test suite. So given the input, let's say https://blog.boot.dev, I want to do a couple of things. The first thing I want to do is strip the protocol. Okay, I don't care about the protocol. In fact, let me add a path here. Let's say slash, let's just call it path, /path. Okay. This part of the URL, the domain and the path, effectively make up the page, right? Query parameters, protocols, all that other crap, we don't really care about when it comes to what page does this URL represent. So given this input, I expect the output to just be blog.boot.dev/path. Protocol is gone. So I'm going to call this test normalize URL strip protocol. Okay. And now if I were to run npm test, I fail, right? Because I have not gone and fixed my code up to actually do that. So let's go ahead and do that now. Hop over to crawl.js. The way I'm going to implement this function is to use the built-in URL constructor. We actually used it in the course. So I'll do const URL object equals new URL and pass it the URL string. So this will give me a URL object that has a few properties on it that are interesting. The first is the host name. So let's do return a new string template literal. And the first part of the string will be URL object.hostname. And the second part will be URL object.pathname. So we are parsing the URL string into a URL object and then saying all I care about is the host name and the path name, and I'm just going to kind of shove them together and return all that as a string. Let's see if that works. We're good to go. The next thing I want to make sure that the normalize URL function handles is trailing slashes. So let me add a new test suite here, or a new test to my test suite. And what I'm going to do is add a trailing slash on the URL. So that slash right there. It's pretty common on the internet to have URLs that end in slashes as well as URLs that don't. But generally speaking, we expect a page with or without the slash to both kind of go to the same place, right? Go to the same web page. So what we're going to do is just trim trailing slashes in the normalize URL function, so that if we're given a trailing slash, we'll just take it off. That way, again, everything comes out to kind of one string that identifies a given web page. Okay, so if we just run our test now with this new test, we're failing, right? Because we don't have any logic that strips that last slash off. So let's go ahead and add that. The first thing we can do is write a little test. We can say if URL object, URL object. So let's grab the, we'll call this the host path. And we can say if host path.length is greater than 0, so if there's at least something there, and host path.slice, so -1. So this dot slice method on a JavaScript string, this will return just the last character of the string. So given that there's at least one character, we're just going to go grab the last character and check, does it equal a slash? So if the string has a slash, then we want to return everything up to the slash. So we'll do return host path.slice, and this returns a subset of the host path string from 0 to the last index. So this is everything except the last character, right? Slice at -1 is just the last character. Slice from 0 to -1 is everything except the last character. Otherwise, if it doesn't end in a slash, we can just return host path. Cool. That seems right. Let's give that a run. Cool. We got it. So now that we're stripping trailing slashes and we are stripping the protocol, let's add just a couple more tests. Make sure that we are doing a few more things that are important in terms of normalizing these URLs. The first is capitals. Capitals. Oh, also, this is bad. We should rename this test. So this first test, sorry, strip protocol is good on this first one because that's what we're doing. This one we should say strip trailing slash. And this one, let's do capitals. So blog.boot.dev/path, remove that trailing slash. This should not remain capitalized. Right? Capitals in a URL don't matter. They should be case insensitive. So we expect to normalize it down to lowercase. Go ahead and run that and make sure it works. It does already work, which is awesome. I mean, you'll notice that we don't really have any logic that deals with lowercasing a string, but the URL constructor is actually doing it for us because it knows that URLs are case insensitive. That's great. We made sure that that works. Let's add one more. Let's just make sure that another protocol is also stripped properly. We'll just do the HTTP protocol and omit the S. Make sure that that works as well. Again, I'd expect that same output. I'm going to remove those capitals though, just so we don't get confused what this test is about, and change this name to be strip HTTP. Cool. Yep, still good to go. Now that we've got that function tested and working, I'm going to go ahead and commit that to source control as well. Well, normalize URLs, normalize URL, sorry, it's singular, and tests. Push that up. Next, we're going to be adding another function called get URLs from HTML. And in order to write that function, we're going to need a new dependency. That dependency is JS DOM. So the interesting thing about this dependency, npm install JS DOM, is that it's not a dev dependency. So you notice we're not doing the -- save dev when we install it. So I'm going to go ahead and run that. And it should add it to our package.json, this time, again, not as a dev dependency, but as a normal dependency. And the differentiation here is that dev dependencies are just intended to be used by the developer, whereas dependencies are intended to be used by the application when it's running in production. So we're actually going to be using JS DOM in our production code, crawl.js, rather than just our test suite, right, which is where jest is used. So let's stub out the get URLs from HTML function. We'll just add it right here above normalize URL. So get URLs from HTML. I'm going to take two inputs. The first will be an HTML body. It's just a string representing some HTML. And the second input will be the base URL. Again, another string. The base URL represents the URL of the website that we are crawling. So HTML body, HTML of the page, base URL, the URL of the website that we are in the process of crawling. And then it just returns a string. Excuse me, it doesn't return a string. It returns an array of strings representing URLs. So we'll do URLs equals empty array. And then for now, we'll just return that empty array. Again, we're just stubbing out the function so that we can go write some tests for it. Let's not forget to export the get URLs from HTML function down in the module.exports. And then over here in crawl.test.js, we can import it. Cool. And now let's add some more tests. So the first test for this function, let's name it properly. Call it get URLs from HTML. Let's just stub everything out. So the first input, because there's actually two inputs to this function, right, is some HTML. So let's write some very simple HTML. Have an opening HTML tag, do an open body tag, add a link. We'll have the link just go to the .dev blog. The anchor text of the link, we can just do boot.dev blog. Okay, little snippet of HTML. Again, this is just a string. In JavaScript, when you use backticks, it allows you to do kind of a multi-line string. So this will be the first input. We'll just call it input HTML body. Then we need one more input, right? Because our function takes 2 arguments. So we'll do const input base URL. And in this case, the base URL will just be that blog.boot. Cool. Now we need to call the function that we're trying to test, which is get URLs from HTML, and pass it in its inputs. So input HTML body and input base URL. Now we need to specify our expected value. So the purpose of the get URLs from HTML function is to grab all of the URLs or links embedded within an HTML page. So when we visit a web page and there's tons of clickable links, we want to grab all of those clickable links out of the document and kind of return them in an array of strings. So taking a look at this HTML document, there's one link in here, right? And it's this link to blog.boot.dev. So we want this link to come back here in the return array. Okay. Now, if you're not familiar with HTML, that's okay. It really isn't too complex. Let me explain what this is. So HTML is just a markup language that the browser uses to structure a web page. And this top level HTML tag is just saying, hey, this is some HTML. So that's not too interesting. The body tag essentially says, hey, this is what you're going to see on the screen. And then A tags are links, where anything within the href property, right, in this case, blog.boot.dev, is what we're going to link to. So when you click the link, that's where you're going to go. And then the text within the A tag is the kind of word you see that's clickable. So this would render to boot.dev blog as, that underlined clickable text. And if you click it, it would take you to the boot dev blog. So now that our test is written, let's go ahead and run the test. And I would expect it to fail, right? Yep, it's failing because we're just getting back that empty array, and we are saying we expect an array with this value inside it. Cool. Let's go actually write the code so that we can pass the test. We'll be using the JS DOM package, right? The one that we already installed. And so I'll import it over here, JS DOM. The way I know how to structure the syntax is because I went and read the JS DOM docs, which again, I'll link to in the description below. But that's what I'll be consulting on the side over here. The JS DOM equals, and then we'll just require the JS DOM package. So the way JS DOM works is it basically gives us a way in Node to access DOM APIs, or document object model APIs. So what that looks like is we create this little DOM object by calling new JS DOM and passing it some HTML. Give it this HTML body. So it's taking that HTML as a string and it's creating a document object model, basically an in-memory object that represents that HTML tree structure. So now we can just use dom.window.document.get, I think it's get, no, query selector all. That's the one we want. And we pass in the name of the tag that we are interested in. So this will return some link elements. Okay, so this syntax, window.document.querySelectorAll, this is the kind of syntax you would use in the browser to work with the document object model, or the DOM. Again, this package, JS DOM, is allowing us to do that in Node, so that we can write, a command line script that interacts with the DOM and crawls web pages. The reason we're passing in A here is because what we want is a list of all the A tags in the HTML. So this gives us a nice little array. So now let's loop over that array. So we can do const link element of link elements. And for now, let's just log these out to see what they look like. So a link element is an object that has a property, and the property we're interested in is the href property. Again, that corresponds to the link text. So href, this should just be a string. Let's just log those out and see if we're on the right track by rerunning our tests. They failed again, which we expected. That's fine. Up here at the top, it does any console logs from the code itself. And yeah, it looks like it's logging out that link text. This is exactly what we want. Now that we know that's working, let's just go ahead and append that to URLs. So URLs dot push that link text. Cool. So we should be iterating through all of the links in the HTML and appending them to that array and returning them. Let's see if that fixed our tests. Awesome. We're all green, all passing. Let's add another test case. As it turns out, we don't just want to pull out absolute URLs, but we also want to pull out relative URLs. So let's rename this, because in this test, we are testing absolute URLs. And let's make a new test. Oops. Hard to work with VS Code so zoomed in. And we'll make a new test where we test relative URLs. Okay, so a relative URL is a URL that does not include the protocol and the domain. It just includes a path. So in this case, let's just call it path. And just to show you what I mean, I'll update this test to contain a path. It'll look like this. Now, down here, this relative URL is the same as this absolute URL up here, because the way the browser works is it looks at what domain you're on when you are viewing a page, and all of the links in the page, if they are relative, which means they start with a slash, it will assume that they are kind of attached to the same domain. So if this is a relative URL slash path, and this is the base URL, then the actual URL, when you click the link, would be the same. It would be blog.boot.dev/path. We don't want to bring this out. We don't want to extract it from the get URLs from HTML function as a relative URL. Instead, we want to kind of combine it into a full absolute URL so that we can actually make requests to it later. So hopefully that makes some amount of sense. Basically, at the end of the day, what it means is if this relative URL is in the HTML and this is the base URL, we want to pull it out as a full URL. Looks like this. Okay, go ahead and run that test. I'd expect it to fail because, yep, we're pulling it out as a relative URL and we want it as the full absolute. So let's go ahead and write some logic that satisfies that test. So the first thing I think we should do is kind of break down the logic tree based on whether we're working with absolute or relative URLs. So we can write a little test by saying if link element.href.slice from 0 to 1 slash. So if the first character in the string is a slash, then this is a relative URL. Relative. Otherwise, we're working with an absolute URL. Now we know our logic works for absolute URLs, so we can just throw that in there. For relative URLs, we need to do something just a little bit different. Right? We're going to want to push urls.push the base URL appended to the relative URL. So we get an absolute URL, right? So we could do something like this. Base URL, oops, evaluate that properly. And link element.href. Right, so now we're concatenating them together. All right. What happens when we run that? We passed. Next, let's add a test that pulls out multiple links. So I'm just going to copy this. In fact, let's have it do both a relative and an absolute URL. So we'll grab that full absolute URL here. And we'll do, let's just call them path 1 and path 2. And then we would expect to get back path 1 and path 2. Take a look at that, make sure, I'm just going to say the blog path 1 and boot path 2. Take a look at that. Yeah, that looks right. And I don't think we'll need to change our code to pass this test. Hopefully this just works. Yep, we're good to go. One last test for this function is that I want to make sure that if we're given a bad URL, that we don't include it in the extracted URLs, right, that come back from the get URLs from HTML function. So let's write an invalid URL here. Let's just say invalid, right? Invalid URL. Now, this is invalid because this isn't a relative URL. It doesn't start with a slash, and it doesn't start with a protocol either. So it's not an absolute URL. So if this were rendered in a browser, this would just be a broken link, right? Invalid. So what do we expect to happen? Well, given these inputs, I expect our function to not extract any URLs. Let's go ahead and run the test and see if it works in its current state. No, we are failing that test. Looks like we expected an empty array and we did get back that invalid string in the array. So let's go fix our code. One way we can test for URL validity is just to use that same URL constructor that we used in normalize URL. Go ahead and do that. So say const URL string, this same thing. Actually, let's do URL object. Let's just parse it directly into new URL object. Now, if the URL constructor is given an invalid URL, so if this string is not a valid URL, this will throw an error, okay? So if it doesn't throw an error, we should be safe to push the URL object's href property, which is just the stringified link, right? However, if it does throw an error, we need to be able to catch that. So let's do try. Throw all this in the try block and then catch error. And if we get an error, we'll just log it out. So we'll do console.log error with relative URL. It's going to be error.message. And the reason there's a .message property here is because this is an error object rather than just a string. So that's how we access the error message. Cool, and then we're going to do a similar thing for the absolute URL. Except, of course, we don't need to parse it this way. Cool. This should work, right? If the URL constructor throws an error, we'll catch it. I should probably fix that copy pasta, absolute URL. And let's go ahead and rerun the tests. Awesome, looks like we passed now. And if I scroll up, yep, there's a console log there saying error with absolute URL, invalid URL. Now that we've got that all working and tested, let's go ahead and commit it. It was the get URLs from HTML function and tests. And I'll push that up. Let's get back to the actual application. So far we've been writing these helper functions, right, in the crawl.js file. And we've written some tests to make sure they're working, but our actual program still just prints hello world. So let's update that a bit. For now, what I think we should do is write a main function. So this will be the entry point to the application. And all it should do at this point is process command line arguments. So at the end of the day, our script is going to take as input a website and crawl that website. So we need to be able to take that input from the command line. And in Node, this is pretty easy. There's an object kind of at the global level called process, and argv is a property that we can use to grab the command line arguments. So within the main function, let's go ahead and check to make sure that the command line arguments have been passed in properly. So if process process.argv.length is less than 3, and we'll say no website provided. And if everything goes well, we'll just print console.log starting crawl. All right, let's test that really quick just to make sure it's doing what we think it is. So when I run npm start, what I'm expecting to happen, by the way, I should probably also like exit here or something. Okay, cool. That same process object has a process.exit. And then we can pass it an error code. Yep, code. Okay, so 1 is a pretty standard error code when things go wrong. So if we have not been given enough command line input, we'll log this and error. So let's just run that. See, yep, no website provided, and it errored. And then let's see what happens if I do provide. Let's just give it the name of my personal blog. Starting crawl. Okay, perfect. So you might be wondering, why are you checking for length 3? Wouldn't it be like 1 or something? Well, let's print out each entry so that you can see what's actually in that argv. So let's say arg of process.argv console.log. Okay, so what are the arguments? Interestingly enough, when I give it one command line argument, the length of this array, process.argv, is actually 3. The first argument is the interpreter, which is kind of strange, right? It makes sense if you've done some more, I don't know, low-level programming, but basically the first argument to any program is always the name of the program. That's just kind of how these operating systems work. So Node is technically the name of our program because Node is what's running and interpreting our code because we're using an interpreted programming language, right? The second argument to our program is the name of our code or the entry point file, right? In our case, main.js. So this is just that full path to main.js. And then the third argument, finally, is the one that we are actually passing in to our program. Let's fix up this typo, provided. And let's make our checking just a little bit more robust. So if it's less than 3, we're going to say no website provided. But I also don't want people thinking that they can pass in, a second website, right? Like boot.dev or something like that. That's not going to do anything different. So we should probably add another check and say if it's greater than 3, so more than the kind of standard amount of arguments are provided, we'll say too many command line args, and we'll exit. So by now we should know that we have exactly 3 command line arguments. So the base URL that we'll be crawling is going to be process.argv at index 2, right? And now let's update this log statement to kind of echo that back. Say starting crawl of base URL. Cool. Make sure that works. Oh yeah, I should probably provide a website. Starting crawl of wagslane.dev. Perfect. Let's start actually crawling some web pages. So now we're going to get to the HTTP part of this project. Let's hop over to the crawl.js file, and we're going to create a new function called crawl page. And as input, it'll take a current URL. And to start, let's just log that we're crawling the page. So console.log actively crawling current URL. Cool. Next, let's make a fetch request to that URL, right? So this is going to be a get request because we're hoping to get back some HTML. So const resp equals wait. We should probably await the promise, but we're using the fetch API. And then we don't even need to specify options. Kind of by default, fetch does get requests. So we can just fetch that current URL. You'll see this red squiggly here. That's because this actually needs to be an async function. So it returns a promise. Oops. Async function. What do we do with the resp object? Well, for now, let's to start, let's just log out the response body. We do resp.text. So this might be new to you. You'll remember that when we were working with the JavaScript, the JSON APIs, right, in the course, we were often using .json, and that's because we expected the response body to be formatted as JSON. Well, now we're expecting the response body to be formatted as HTML, so we're going to just parse it as text, again, because we already wrote get URLs from HTML, which takes HTML like as a string, as text, as input. So we can just kind of grab it as text. Cool, let's run this. Actually, we're gonna need to hook it up, right? We need to hook it up to main. So let's import const crawl page equals require, and it's going to be crawl.js. Here we can just crawl page and give it that base URL. Okay, so let's rerun our application and see if we make that GET request properly. And again, this is just my blog. It's a little website with about 20 pages on it. It's not huge. You can use my blog to test. I don't care. Or you can use a different website. If you are going to use my site, please don't DDoS it. I'd really appreciate that. But anyways, let's get going. Crawl page is not a function. I'm a big idiot. I didn't export this. Try again. Let's see. Starting crawl. Actively crawling. Okay. Is that what we expect? Did we log anything? Log resp.text. Yes. Probably await that. This .text method returns a promise. So let's await the promise and log it out. Awesome. Okay, now we're getting some HTML, right? So this is all the HTML on the home page of my blog. It's just a big fat dump of HTML data. So we have a problem. If a user types in bad input, so let's do npm start and then http garbage URL, right? Just an invalid URL. At the moment, our code just kind of panics and dumps out the stack trace. We don't want that for a couple reasons. The first is this isn't a very good user experience. We probably should give just a prettier error message and exit cleanly when there's bad user input. But also, as we crawl pages, because we're going to be crawling multiple pages with our website or with our tool, we don't want to encounter one bad link and have the whole process just kind of vomit and exit. We want to be able to handle that and keep moving and keep crawling more pages, even if there's an invalid link somewhere on a website. So let's add some try catch handling here. That will be step number 1. So this fetch call can error, so let's throw it within a try block. and then we'll catch the error and log it out. Console.log error in fetch. Page current URL. Cool. And let's try running that. Cool, much better. We don't get a huge stack trace. We just log out a little message here. So you may have noticed this little warning here. That's because fetch historically was only available in the browser environment, and we're running JavaScript now on the command line using Node. Recently, Node did add support for the fetch API, right, for this fetch call as a built-in, but it's still considered experimental. They could rip it back out. I think that's unlikely. I think it's likely here to stay. If for whatever reason they did rip it out, we could always install Node Fetch, which is a package that does essentially the same thing. But in order to ignore this warning, because I'm aware of the fact that it's experimental and I don't want it telling me that every time I run my program, I'm going to come in here and pass the no warnings flag into the Node interpreter. And so now if we run it, we don't get that warning. So we've checked for an error in the fetch call, but now I want to check for some more things because there are some other things that could go wrong. The first thing is the status code, right? We need to check and ensure that the status code of this fetch request is a 200 level code. If it's anything over, well, I guess 300 would be okay as well. We're okay with a redirect, but we shouldn't be in the 400s or above, right? The 400 level, 500 level error codes. So I'm going to write a little if statement here that says if resp.status is greater than 399, that would mean, again, 400 client error, 500 server error. Then let's log an error and say error in fetch with status code. Status code on page. That current URL. And if that happens, then we'll just return. We'll just stop crawling this page, right? If this page is broken, we're just done. We can just return from this function. Cool. Let's go ahead and make sure that is working. So if I crawl a valid URL like wagslane.dev, we get the HTML. So that's all still good. Now let's try a URL that doesn't exist. So I would expect this to result in a 404. So I'm just going to type in like a garbage path. Cool. Error in fetch with status code 404 on page garbage path. That seems to be working. One last thing I want to check just to be really sure that everything in this function is going off without a hitch is that we are actually getting HTML back. So when we parse the response body, right, does it actually contain text that represents valid HTML? And the way I'm going to do that is just by parsing the headers. So we can do this. Const content type equals resp.headers.get, and we'll grab that content type header. And then we could say if content type, got my parentheses, content type does not equal, going to be text HTML, then we'll want to throw a similar log and say non-HTML fonts to non-HTML response, content type there, content type on page. Okay, cool. How do we test this one? So we want a valid URL. It doesn't have an HTML response. My sitemap. Let's use my sitemap. So my sitemap is not HTML. It is XML. So if I do sitemap.xml here, we should trigger this. Awesome. Non-HTML response, content type, application XML on page. Okay. And then let's just make sure that we didn't break kind of the normal flow of things. Text HTML charset UTF-8. Ahaha. Okay. So what we should probably do then is maybe do an includes here. So rather than saying the content type is text HTML, because that header can have additional information like the character set of the response. So it is valid HTML, but it's also giving us kind of an encoding type. So I'm going to change this to .includes text HTML. Now, as long as that string is in the header, we'll be good to go. Run that. What did I do wrong now? Content type .includes text HTML. Oh, it does not include text HTML. Making all sorts of embarrassing mistakes. Cool. There we go. And just to be super sure, let's make sure that I didn't break that. Okay, perfect. Now that we're grabbing HTML with some basic kind of error handling, let's go ahead and commit this. Crawl page. Let's just say crawl single page with error handling. And we can push that up. Now it's time to update the crawl page function so that it can crawl an entire website rather than just a single page. So instead of just accepting a current URL, it's going to have 3 arguments. There's going to be a base URL, a current URL, and a pages object. So the base URL is going to be essentially the starting point, right? The home page of the website typically. The current URL will be the page that we are actively crawling. And then the pages object is going to be an object that keeps track of all the pages we've crawled so far. First, we need to make sure that the current URL is actually on the same domain as the base URL. We don't want to crawl the entire internet here. Whenever we encounter a link that links out to an external site, we basically just want to ignore it. So we can do that by using the new URL constructor, right? So we could say base URL object, make that a const, equals new URL, base URL. Do that with the current URL as well. And say if base URL object dot hostname does not equal current URL object dot hostname, then we can just return early. And actually, what this function returns isn't nothing anymore. It returns the pages object. That's going to be how we keep track as we call crawl page multiple times. It's going to be how we keep track of all of the pages that we've already crawled. So we can return early and just return that same pages object that we received as input, because if these host names are different, we're going to skip this page. Next, we need to see if we've already crawled this page, right? So let's grab a normalized version of the current URL. So const normalized current URL. And we can just use that normalized URL function. Cool, let me expand this so we can see more code. Okay, so we can just call normalized URL and give it the current URL. So the way we can check if we've already crawled this page is if the normalized current URL exists within the pages object. The pages object is essentially just a map of URLs, normalized URLs, right? So we don't get duplicates, to the number of times that we've seen that URL or that we've crawled that URL. So what we can say is if pages at normalized current URL greater than 0, then we can just increment pages at normalized current URL, so plus, and return pages. So we're basically just saying, if I've already seen this page, I'm going to increment the count, right? The number of times I've seen this page. And this is so that when we actually go generating a report, we can tell the user how many times a certain page is linked to on the site. So if we already have an entry, we increment it and return. Assuming we've made it this far, we do not yet have an entry for the normalized current URL. So let's create it, and we'll initialize the count to 1, right? This is the first time we've seen this URL, or that we're crawling this URL. Next, I'm going to move this log statement down where the crawling actually happens. If any of this happens, right? If we're seeing an external link, or if we're processing a link that we've already processed, I don't want to be logging this crawling message over and over and over again. I only want to log it when I'm crawling a new page. So after logging which page we are crawling, we'll go ahead and fetch the page just like we were before. But instead of logging out the HTML, that's something we definitely don't want to do. Let's save it in a variable. Const HTML body response.text. And the next step will be to extract all of the links from the HTML so that we have more pages to go crawl. Luckily, we already wrote and tested that function. So we can do next URLs equals get URLs from HTML, and we'll pass in the HTML body and the base URL. And let's save that as a const. Cool, now we can iterate over the next URLs. So const for const next URL of next URLs. Now we're going to recursively crawl these pages. So if you're not familiar with recursive functions, a recursive function is just a function that calls itself, right? So we crawl the root page, and then we find all the links in that page, and then we crawl those pages, and those may have links, and we'll continue to crawl all of the pages on the website until basically these base cases are completely satisfied, right? Either we're just hitting links that are external to the site, so we're not going to crawl those, or we're just hitting links that we've already crawled. So we should just exhaustively crawl the entire website. So we're getting a new pages object, right? Because remember, now this function returns a pages object. So pages equals await crawl page, and we need to pass in the same base URL, right? But now, rather than passing in the current URL, we'll pass in the next URL as kind of the next current URL, right? And then the current value of the pages object. So we're getting back kind of a new updated pages object. We're giving it the old one. And then when we're done with that, so once we've crawled every page, then we can just, at the end, return the pages object, right? That makes sense to me. Let's go update main.js so that it actually works the way we'd expect. So now the crawl page function takes 3 arguments. To start, it will take the base URL twice, right? We'll pass in base URL not only as the base URL, but also as the current URL because it's our starting point. And we'll start with an empty object for the pages object because we haven't crawled anything yet. That object will get filled in as we recursively crawl more and more pages. And then let's save the result in a pages object. And for now, let's just log those out. So for const page of pages, we'll just log out the entire page object. Cool. Let's go ahead and run this and see where it gets us. So I'm going to, again, just crawl my blog, see what happens. And we already screwed up. What do we got? for const page of pages. Pages is not iterable. That makes sense. This was, for some reason in my head, I thought this was an array. It is an object. So we need to do object dot entries. That will allow us to iterate over the entries in the object. Okay, let's go ahead and run that code again. Cool. Another issue here. Let's see, cannot read properties of undefined after hitting this XML page. Oh, you know what? We've got a return in here. Remember that we always want to return the pages object. So even when there's an issue, we still want to return the current pages object. We're relying on that. Okay, let's fix that and try again. Cool, so it looks like it's crawling. That's good. We crawled a bunch of pages. We didn't see anything on the other side here. So when we iterated over this at the end, oh, you know what? Crawl page returns a promise. Let's not forget to await that. And the main function also needs to be asynchronous. Right? Okay, let's try that. There we go. Now we're seeing some results. Okay, so we crawled through all the pages on the site. That's great. We even handled the sitemap. And this is what we got out the other side. So we have this giant list of all of the pages and how many times they're linked to. So that's great. This is the data that we need now to do the last step, which is building a report of all this information. And before I forget, let's go ahead and commit all of this to Git. Don't lose our work. So crawl page recursive. Let's convert this kind of nasty just dump of JavaScript objects and arrays into a nice report. To do that, I'm going to create two new files, report.js and report.test.js. There'll be one function we write that I think is worth writing some unit tests for. So the function that we'll be writing a unit test for is called sort pages. So function sort pages. As input, it takes that pages object and it's going to return an array. So for now, I'm just going to stub this out, have it return an empty array. Let's hop over to the test and let's grab a test. Give us somewhere to start. Instead of testing stuff in crawl.js, we'll be testing within report.js, and the function we care to test is called sort pages. Okay, so sort pages. All right, the input is a pages object. So let's build kind of a manual pages object. So it could be something like https://wagslane.dev. And remember, each URL maps to how many times that URL shows up as a link on the website. So let's just do 3. Okay, so it's a very simple pages object. And then we'll call sort pages. And the expected in this case be an array. And it will be an array of, I believe we want it to be an array of essentially tuples, which are basically just an array of arrays, where the first index in the array is the URL, and the second index in the array is the number. So in this case, the expected would look something like this. And then the whole point of sort pages is it actually sorts the output array, putting the kind of highest count URLs at the top, lowest count at the bottom, or first and then last. So let's add another entry here. Make this one a smaller count. So that should show up next in the array, right? We want highest to lowest, should come after. Okay, so hopefully that makes sense. Taking this object as input, we're converting it to an array, and we're sorting the array. First index is the URL, second index is the count. Okay, that looks pretty good. Now, we haven't actually fixed up our function yet, so I'm expecting this test to fail. npm run test. Cool. One test is failing, right? This is what we expected, and we should have got an empty array. Am I reading this wrong? Actual sort pages input. Sort pages is not a function. Okay, so I forgot to export, of course. Module dot exports sort page. Now we can actually import it and use it. Let's make sure that works. Okay, now we're failing for the right reason. We have unexpected input. Okay, cool. Now let's go ahead and write the sort pages function. So the first step is just to convert this into an array. So pages array equals object dot entries pages. Now, it's important to understand the way this function works is it will take the pages object and convert it into that structure that we're expecting, right? An array of arrays where the first index is the key in the object and the second index is the value. So this gives us the structure we want, but now we need to sort it. So we can do pages array dot sort. JavaScript has a built-in sorting function, but we need to tell it how we want to sort, how we want it to sort all these entries. So A and B represent two individual entries in the pages array, right? So two individual arrays. And the kind of value that we want to sort on, so A hits is A at 1, and B hits equals B at 1. Remember, because index 1 has the count that we want to sort by, right? Index 0 has the URL. Okay, and then what this compare function returns is a number. And because we want to sort from greatest to largest, we'll want to return B at 1 minus A at 1. Essentially, the way the sort function works is whether it's given a kind of positive or a negative return value is how it sorts all of the individual entries in the array. I'd encourage you to go take a look at the documentation on the sort function if you're a little fuzzy on how that's working. But if we wanted to sort the other way, we could just swap this, right? A minus B. But because we want to go greatest to least, we'll do B minus A. Cool, and then we just return the pages array. Let's see where that gets us. Awesome. We passed that test. Let's go ahead and write another test just to be sure that the sort is working, right? We were only really sorting two pages here. So two sort pages, 2 pages. Let's do something a little bigger. Let's do like 5 pages. And I want them all out of order in the input object. Two, 3, 4, and let's just go way out of order here. All right. 1, 3, 2. That's super out of order, right? Cool. And what do we expect from this? Well, we expect 9 to be at the top. Just copy pasta some of these. So path 4 9 hits at the top. Next, we'd have path 2, 5 hits. Next, we would have 3 hits, and then path 3, 2 hits, and finally, path with 1. Okay, let's make sure that test passes as well. Cool, we're good to go. So now that we have sort pages working, let's write one more function that will format the entire pages object as kind of that beautiful report in the console. So this one we're just going to call print report. Takes pages as input. And the first thing we're going to do is kind of separate. If you remember, our program as it crawls kind of writes some stuff to the console. So I think we really want to separate all of that text from the report itself. So I'm going to go ahead and log a bunch of equal signs to the console. And then something like report. Maybe another one of these. Okay, then I'm going to get the sorted pages. So const sorted pages. Pages, path in the pages object. Cool. Then we could iterate over all of the sorted pages. So for const sorted page of sorted pages. And remember, each sorted page is an array, so we can get the URL is sorted page at 0, right? And const hits is sorted page at 1. So the page URL and how many times it appeared in the site, how many times it was linked to, right? Then we can log an entry and say something like, how should we reformat this? Found links to page URL. That. And then let's end the report. Similar kind of output. Cool. I think that'll look good. Now we can hop back over. Well, let's not forget to export this. Now we can hop back over to main.js. Let's import print report. And now, instead of this nonsense, we can just call print report pages. Cool. After all that, let's go ahead and run it again. So npm run start. Start it from the root of my blog. Right. Crawling. Awesome. Okay, so actively crawling all the different pages. That's great. Report starts. 61 links to the home page, 60 links to tags. So it makes sense that these have lots of links because they're kind of in the menu of the site. So essentially every page links to those pages. And then these are links that are actually found kind of within the body text of the individual posts. If you've gotten this far, great. You've got a working web crawler. I'd encourage you to update and enhance your web crawler, test it on different sites, see if there's any edge cases in the code that maybe we're not handling. And this will make a great kind of base project for you to build on top of and add to your portfolio. Of course, don't forget to commit your code. Print report finished. Push it up to either GitHub or GitLab or wherever you store your code. Again, I'd encourage you to extend this project if you want to make it part of your portfolio that you're showing off to employers and that sort of thing. There's plenty of things that could be improved here, right? Maybe instead of logging the report to the console, maybe you create an Excel spreadsheet in CSV format. But at the end of the day, the more personal you can make it and the more functionality you add to it, the more impressive it will look on your portfolio.